So this is ESQ2. What are the degree and lead coefficient of the polynomial? Now, to do that, what you first have to find is the highest power. So out of these terms, this piece has the highest power. The degree is that highest power, so it's a fourth degree. And then the lead coefficient is the 20 right here. Now, it's going to be important for other problems to notice that negative or positive as well. So if that was a minus 20, you need to put a negative 20 here as your lead coefficient, because that negative and positive are important for other problems. So for this problem, we want to choose the end behavior that fits it. Now, when you're on ALEKS, you're going to be choosing from these A's and B's, but on the written quizzes, which are for our quizzes, you would just need to draw these little arrows, and they'll describe what's happening on the edges. So, if we look at this first one, it's a 6th degree with a negative lead coefficient. So 6th degree, negative lead coefficient, and a 6 is an even number. Now, with a negative lead coefficient, you know your right side is going to be dropping, and since it's even, the left side is going to be doing the same direction. This is a 3rd degree negative lead coefficient. 3 is an odd number. So with the negative lead coefficient, right there, you're always going to drop as you go to the right. And since it's odd, you go the opposite direction as you go to the left. And then when you have it here in factored form, you just add the powers. You get 4th power, which is a 4th degree, which is an even. And the number in front is a positive. So since it's positive, you're going to go up to the right. And since it's even, you're going to go the same direction to the left. And then how we chose these is just, you just kind of read it carefully, and you can be able to choose these. But on the written test, you can kind of draw this, or you might actually have to maybe box or circle the right answer here, depending on how we write it. The key thing to remember is on all evens, they go the same direction. On all odds, they go opposite directions. And on a negative lead coefficient, the right side always drops. On a positive lead coefficient, the right side always goes up. Those are key ideas. Below is the graph of a polynomial function. Now we're going to answer these questions, and all local extrema on f are shown in the graph. So you look carefully at the graph to see it. So anyways, A, the function f is increasing over which intervals? Well, intervals that it's increasing are here in red, right there in red, and right there in red. Those are where the graph is going uphill. It's called increasing. So the intervals for that is this is for the first red. It's from negative infinity to negative 7, because right there is negative 7. Then negative 2 to 4 is this next one. So from negative 2 to 4 is that interval. And the last one is from 8 to infinity. So from 8 to infinity, it is also increasing. So those are the 3 spots where I highlighted in red where it's going up. The function f has a local maximum at which x values. If there's more, just follow the directions if you're writing it. So with this one, local maximums are hills. So the local maximum is at negative 7, I have a hill, and at 4, I have a hill. All at once is the x value where you have your hill. If I want minimum, it would have been at 2 and at 8. Next, what is the sign of the lead coefficient of f? Well, lead coefficients are based on the far right, what is happening. In the far right, you should see it's going up. So I know the sign of the lead coefficient is going to be a positive. If it was going down, it'd be a negative. And the last one, which of the following is a possibility for the degree of f? Choose all that apply. Now, since they go the opposite directions, we know it has to be odd. So I could throw out 4, 6, and 8 can be thrown out. Now the next question is, why did I choose 5, 7, and 9, all of them? Well, because if you look at the graph, all right, the number of max and mins is 1. I have a max, a min, a max, and a min. Can you see I have 4 local extremas? If I have 4 local extremas, that means that the lowest the power could be is 1 higher than that, so it's a 5th degree. So 5th degree is the lowest it could be. Now, it could be a 7th or a 9th. It could be higher than that, but it cannot be lower than a 5th degree because of the number of maxes and minimums. For this next question, find the polynomial f of x of a fifth degree 5 that has the following zeros. Now what this multiplicity means is you have 2 9 zeros, which basically means it's going to be a bounce. And what we learned in the past is bounces have this squared effect. Now, since my zeros are 9, -7, 0, and -1, what I do is the opposite of them are your factors. So, f of x equals, now why did I just put x here? Because really it's x plus or minus 0. So that takes care of the 0. Now, the x minus 9 comes from, well, 9. 9 minus 9 is 0. So, again, the opposite of that is the factor. And we have a squared because of multiplicity of 2. If I had a multiplicity of 3, that would be a cubic. The -7 would be an x plus 7. Remember, the opposite is the factor of the actual 0. We did 0 already. That took care of that one. And -1 would be an x plus 1. That right there is a factored form for a fifth degree that has these zeros. We could verify the fifth degree as well because I have a 1, 2, 3, 4, 5. If you add up all the powers. Again, that's 1, 2, 3, 4, 5, which is a fifth degree. For this last problem, we want to find all real zeros of the function. So what you do is you find out what makes all of these equal to 0, because those make zeros. So these are easy because you just notice, well, what's the opposite of -7 is positive 7. But what you're technically doing is setting this equal to 0 and solving. You're setting this equal to 0 and solving. You're setting this equal to 0 and solving. So this one would be a 7. This one would be a -7. And when you solve this one, you see a plus or minus 5. So that is why we get all 4 zeros. Another way to look at it, which you could also do, is to factor this one, is called a difference of squares, as x minus 5, x plus 5. And when you see factored form, you'll notice these two, a plus and -5, is a positive 5, -5. You see it in the factored form. So instead of solving this, you could have also looked at it in a factored form and see it that way, if that makes more sense to you.